Welcome back to the next Unit 2 video. As you can see, today we're going to look at data transmission over the internet. So a quick overview then. Well, first we're going to look at the internet versus the World Wide Web, right? How they're actually different. Despite how many people use the terms interchangeably in real life. Right, then we're going to look at what internet service providers or ISPs, and what basically they would be the companies that you buy your access to the internet from. Right, then we're going to look at what packet switching versus circuit switching. We'll look at the use cases, advantages and disadvantages of both of these. Right, so just to start then, the difference between, the World Wide Web, right, www, and the internet. The World Wide Web is a collection of web pages linked together and accessed via the HTTPS protocol. Quite a simple definition, but that's literally all it is, right? Just all of the websites, all of the web pages. And of course, when it says linked together, well, that's because obviously, okay, right, well, let's say here, this is website A, and I don't know, okay, well, let's say they have like an index, maybe index.html or something. And of course, from this page, they might have a link to website B, and then obviously, that website B might have a link to website C, right, etc. So I guess, that's what we can say about that. Right, then, if we say, HTTPS, maybe people remember what's the Hypertext Transfer Protocol, and, the S, that just means secure, right, it means it's encrypted. Right, then, in contrast to the internet, that's an internetwork. That's going to be the worldwide connection of devices and infrastructure. So, for example, cabling, satellites, routers, etc. And it's going to communicate over IP, right, so IP, the internet protocol. Of course, right, that can be, version 4 or version 6, which, I think we'll see in a, later lesson. Right, and here we can say that any digital data can be sent, so not only websites or, web pages, but also, media, right, so, audio, video, right, images, of course, emails, files, programs, text, right, again, just any digital data. So what we can say, the internet is therefore a superset containing the World Wide Web. When we say a superset, I think here we can just see in this Venn diagram. So in fact, let's just show everything first. Right, so here, of course, the internet is blue, and then obviously, I guess we can say, contained within the internet is just the World Wide Web. So the internet, I guess clients, it's quite a vague term, of course, that's just what, I guess, our end devices, right, it could be a laptop, it could be a phone, of course, it could be let's say a web browser, an email client, or like an email program, just anything accessing the data. I guess, of course, servers, that's anything sending the data or anything responding with data. So that could be a web server, and I guess, if it's a web server, that's, okay, so I guess a web server is not really, the World Wide Web. I guess you'd really call a web server the internet, because if we think, the World Wide Web is more, it's more talking about the actual kind of pages, right, the digital pages, rather than the physical infrastructure that's kind of, hosting it. But yeah, of course, servers, one, that could be a web server, but it could also be an email server, it could be a file server, it could be, for example, a database server, and of course, file server, that could be accessed via something like FTP, right, the file transfer protocol. Email servers, and that's going to be SMTP, POP3, POP, that's a P, and then, then also IMAP. Actually, these are more A2, so you don't really have to worry about them. But yeah, I guess maybe some people are just curious. Alright then, if we look at some of the protocols, so IP, right, the internet protocol, again, right, version 4, version 6. Then we look at TCP, and actually I forgot what this means. Either it's the transport control protocol, or maybe transmission control protocol. I guess transport, transmission, basically they mean the same thing anyway. So what we can say, TCP is going to have a couple of advantages, because, so basically, right, either we can use TCP or we can use UDP. And maybe let's just sort of mention this briefly. Okay, so IP is going to be a lower layer. Then we're going to have TCP, and TCP or UDP is on top of that. So TCP is going to provide a couple of advantages over UDP. One of them, it's going to be more reliable. So the problem with UDP, and I guess, let's kind of briefly talk about packet switching first. So let's say A, right, that's, I guess the client, right, B, that can be a server, or just someone else you're, communicating with over the internet. Now, of course, what you're going to have, you're going to have some routers in between. So let's say, for example, A, right, maybe first they send to this router, then of course, this packet goes to this router, right, this packet to this router, right, eventually gets to B. So let's say, this is packet 1. Now, let's say, right, A also sends packet 2. Now, the thing is, the packets don't have to travel the same route. So, I don't know, okay, maybe this one goes there, then it goes there, right, then it goes there, then it goes there. Now, let's say, so I guess there's two things that can happen, and I don't know, yeah, okay, let's say packet 3 also goes this route. Now, we could have a situation where, I don't know, okay, right, let's say packet 2 doesn't arrive. So B, well, I mean, what, okay, they're going to receive packet 1 and they're going to receive packet 3. But since they don't have packet 2, well, then of course they're going to realize that, packet 2 has gone missing, right? It's been dropped. Therefore, what's going to happen, right? A is then going to send packet 2 again, right? Since it hasn't received an acknowledgement from B that it's received packet 2. So yeah, that's basically going to be an advantage of TCP, right? It's going to be reliable because, well, basically it's just going to use acknowledgements, like to acknowledge which packets it's received. And of course, well, yeah, okay, and then if A doesn't get the acknowledgement, right, then it's just going to resend. Right, there could also be a different situation where, let's say, I don't know, so let's say 2 is faster. So we might have it where, all right, let's say the data arrives, like 2, 1, 3. Now, of course, I mean, those packets are in the wrong order, right? Therefore, they have to be reordered. Well, obviously, just 1, 2, 3 like this. All right, so that's going to be another advantage of TCP. So, right, basically it's going to do 2 things. Okay, 1, it's going to reorder the data, and 2, packets. Right, and 2, any packets that don't arrive, they're just going to be resent. Now, in contrast, UDP is more simple. Like UDP is literally just going to send them, then it's not going to do any checks. So if the packets arrive in the wrong order, it doesn't really matter. Right, if some of the packets don't arrive, again, doesn't really matter. Right, it's just going to send them regardless. It's not going to do any checks. Now, you might think, well, why would you ever want to use UDP? But a good example could be, for example, streaming, right? Could be, video streaming, right? Phone calls, audio streaming. Now, let's say, for example, you have something like this, okay? So, let's say packet 2 has arrived, but packet 1 hasn't. Now, you can't exactly sort of go back and then ask for packet 1 again, since, if you've already played packet 2, well, that audio has already played. So, like you'd have something, okay, well, let's say they're saying hello, and let's say that, this 2 is the E, for example. So, if they've already, played the sound for the E, well, you can't exactly then sort of go back and play the sound of the H because, well, of course, then it's going to be in the wrong order, right? Like for something like audio, video, right? You're not going to be able to do that. So in that case, I guess you don't really matter because if you think, well, if like 1% of the audio we just don't receive, like probably the person can still understand what they're saying, right? Even if you have like a small number of packets that don't arrive. Well, of course, I'm sure everyone's experienced that where, let's say they're calling someone, or doing like a video call, and then obviously some of the packets just drop. The video cuts out temporarily, and again that's going to be because it's using UDP. All right, then, well, I guess we've sort of mentioned some of the infrastructure already. So of course, the routers, the switches, right, bridges, right, some of the cables. So I guess fiber optic is going to be the main one, right? If you're talking about the sort of global internet backbone. But if you're talking about maybe in residential areas or from I don't know, okay, let's say like from maybe the road right to your house. Now these days, I guess a lot of the time it is fiber optic as well. But traditionally apparently that would be coaxial, right? Maybe even twisted pair. Alright, and then emails, files, or things like SSH telnet. So basically just logging into servers, right? Again, so SSH telnet, right? They're just other protocols. And in fact, these are going to be like HTTP, where what we can say, well, these are going to be application layer protocols, right? So they're going to be even higher than TCP UDP, and then again TCP UDP, right? They're also higher than IP. So we say I guess if we sort of number them in fact, right, actually usually they number them like this. So we say, okay, this is layer 4, right? This is the top layer, application layer, right? Transport layer, well, that's level 3. Right, IP, well, that's level 2. And then I guess level 1 we have the physical layer. So that's gonna be like the I guess kind of like the sort of Wi-Fi, like the radio waves. It can be things like the Ethernet protocol. Although technically, right, that's data link. I think I'm just ignore that, right? It's not really important for AS. And then anyway, right, the World Wide Web. We just said what the web page is, right? Access via HTTPS. Alright, so the infrastructure, so the internet network can be considered a huge WAN or huge wide area network, right? Just all the all the smaller networks connected together. Right, it was never designed as a whole. I guess when they started it, no one thought, okay, well, like obviously, okay, right. So let's say no one thought, well, we need to build servers here, we need to build servers here, we need to build servers here. I guess obviously, they just kind of created their own small network, and then obviously other people then just started adding servers, right? Other people started using it, right? Therefore, it just grew naturally. Right, so because it wasn't officially designed, I guess in some ways you might think, well, maybe it's going to be unorganized or it's going to be chaotic. And to be honest, like if people designed it from scratch now, I mean, yeah, maybe they could have fixed, some of the issues that we have. However, I mean, I guess it has naturally evolved into this hierarchical model. And if we're talking about ISPs, right, so the internet service providers, and again, like if people don't know what this is, right, okay, these would be the companies that you buy your internet from. So, I mean, let's say what your phone contract, well, of course, you're buying your phone contract from, some particular network provider. Of course, I mean, what they're going to be like a mobile ISP. Of course, what your home router, of course, right, you're also going to buy that internet package, yeah, from, another company, right? Right, another ISP. And I mean, probably lots of people have the same ISP for what both their phone and their home, right? It's probably connected. All right. Anyway, here then. So, right. I guess if we're talking about the kind of smallest layer or the smallest level, it's going to be what access or tier 3 ISPs. They're going to allow an individual or business to connect to a regional ISP. So I mean that's yeah, right. Okay. So like sometimes access ISPs, like apparently they can literally be just in one city, right? So super small. All right, then, well, regional or tier 2 ISPs, they're going to connect the local access ISPs and provide, well, national or regional coverage. Right, well, then you've got global or tier 1 ISPs, and, well, as the name suggests, right, provides the global backbone. So, for example, well, the undersea cables, the satellites, yeah, just, the worldwide communication. Now, many ISPs will actually fall into multiple categories. So, well, you think, okay, right, let's say, well, China Mobile, right, AT&T, well, that's in America. Well, BT, right, that's in the UK. So I mean, these ones, right? They're going to be all three, because if you think about that, well, of course, like right. So you can buy your monthly internet package from these people, and so like not only are they going to allow you to connect, sort of to the local, I guess to the local infrastructure, but they're also going to own the national or regional infrastructure. And yeah, all of these companies, right? They also operate global infrastructure. Like again, kind of global undersea cables. I think most of these, probably have their own satellites as well. So that's kind of thing. Okay, some ISPs are just going to be one level or one tier. Obviously, some ISPs are going to be multiple. Right. Okay. So I guess if you're not in China, right, this is not really relevant. But I guess, for example, in China, there's only three ISPs. China Mobile, China Telecom, China Unicom. Right, these three are massive companies, hence provide services from local, right, tier 3, right, to global tier 1. Now, in contrast, in countries like the UK, well, apparently there's more than 200 ISPs. So most of these will actually be tier 3, right, local or access ISPs. Of course, less are going to be regional, and I guess even fewer are going to be tier 1 or global. And again, a few are like BT, Vodafone, right, again, they're going to be all three. Alright, so let's see then how someone might connect, alright, so let's see how a packet might be routed from someone on one ISP to someone else on a different ISP. And don't get confused about, stage 1 to 3, right, in these next slides. Right, that's actually not talking about, tier 1 to 3 that we've just seen. This is just saying, of course, what happens first, what happens second, what happens third. Right, so I guess, the first part then, right, is the point of presence. So here, it's only your provider, only your city. So what you can have, let's say you have, right, where's the pen? Okay, so right, okay, let's say this is you on one network, and right, you might have, let's say, right, another network, and like for example, okay, let's just call this ISP A, right? I mean, it doesn't really matter what it is. Now here, okay, right, let's say someone here, alright, alright, so let's call this network A1, and in fact, hang on, okay, alright, so let's call this B, and of course, alright, let's go AI, right, so the A ISP. Now, if let's say someone on this sort of network A1 wants to communicate here with let's say someone on sort of network B, since they're both using the same ISP, then actually it's easy because of course, right, it can be sent to this ISP's router. This router can of course send it to I guess the other ISP's router, and of course, obviously, right, this router can then send it just to this particular network, and the reason it can do that. And in fact, like actually, okay. All right, so maybe let's call it A again. Now, the reason I'm saying A is because, right, basically we're saying this is the same company. So okay, this, I guess, this router, right, is owned by the same company that owns this router. So of course, right, if they're owned by the same company, then they can just directly communicate. Right, that's going to be quite simple. And here we say, packets are sent to your local ISP's router, again, right, just in your city or region. Right, then there's stage 2, so I guess if you want the regional or national access. Right, so we say packets can be routed via the own ISP's cabling or even shared cables, right, to different cities if possible. Right, okay, I guess if that's not possible, then we're going to need stage 3, which we'll see. And when we say shared cables, well, what you could have is you could have, let's say, a company that's built I don't know, they built some super fast, fiber optic network. Now you might have another company, let's say they don't have enough money to build, thousands of kilometers of fiber optic cables. So what they would do is, they would of course have a deal with this other company that's built them, and they would actually just rent these cables right from that other company. I guess that's what we mean right when we're saying shared cables, right? It's just going to be one company where either having a deal, to allow the other one to use their others for free, but of course it's going to be mutual, or there's going to be some sort of rental, right? They're renting access to the cables. Right. However, if that's not possible, well, then you're going to need stage 3, right? The Internet Exchange Points, or IXP. Right. So the IXP, this is like right. Okay. Yeah. So ISPs, right. Yeah. Sorry. Yeah. IXPs are locations where multiple ISPs meet. Right, the packets can be swapped from one network, or I guess one ISP to another. So let's say, I don't know what this purple is, well, let's say ISP A, of course, the orange, right, ISP B. Now let's say, and again, right, where's the pin? Okay, here it is. Right, okay, so let's say someone up here, right, they want to communicate with, I guess, right, someone here. But in fact, right, okay. So right, let's say it's on this orange network, right? Let's say this one. Now, of course, what they can do, I mean, they've not really. All right. So right. I'm just gonna say there's another another IXP here, right, just to make it easier. So probably what's going to happen, of course, well, I mean, this one, what they're going to send to their own router here, right, again, just on the purple network. Of course, right, what's going to happen, well, then it's going to get to the IXP. And since, of course, we want to transfer onto this orange network, well, of course, then the packets, then the packets are just going to swap over, right, to this orange cabling. Of course, then they're going to go to this orange router here. And of course, this orange router can then, obviously, just forward on the packets, right, to this network. Okay. So I guess, this network, on its own system. I mean, hopefully that makes sense. Of course, it's just saying what the packets can, swap between the different wires, right, at these internet exchange points. Right, as we see here. All right, then if we look at tier 1, so I mean, this is not really related to the previous slides, but it's just showing what the fiber optic cables, right, the undersea cables. And also, I mean, here you can see a huge number. And I mean, the thing to note is that, well, obviously, I mean, like all of these, right, they're all just under the sea. I mean, presumably there's also, lots of fiber optic cables under the land. But I mean, this particular website is right, only showing the ones at the bottom of the sea. And I mean, the thing is, right, if you do go to this website, right, there is a link in a minute. Then of course, right, you can just, click any of these, right. I mean, you can see who owns them. So again, I mean, if we look at this one, and right, okay, so this is why I said that, for example, China Mobile, well, that's going to be what all three, it's going to be an access, right, or tier 3, it's going to be regional tier 2 ISP, and it's going to be a tier 1 or global ISP, since again, we can see here, right, it's actually partly owning, these cables. And if you actually notice, right, there's not just one owner, because, well, I guess it's going to be expensive, right? That's why, of course, what they can do, of course, they can share these cables between all of them, just to, keep the price cheaper. Alright, so if you want to look at that, it's submarinecablemap.com, and I think it's quite interesting, right, just seeing, kind of what ISPs are owning the different cables, right, in your area. Right, so I guess if we actually look at what these look like, well, here then the 3 gold circles, these are actually going to contain the actual fiber optic cables, right? The rest is all just protection. So I guess, maybe have a think, okay, why do you think so much protection is needed, right? If we only have, right, the cables inside these gold, I guess this kind of gold casing. So I mean, like, basically what, it's just going to be extremely high pressure at the bottom of the ocean. Because I mean, if you think, well, I guess, people have seen like the submarines and whatever, they get crushed by the pressure. So of course, that's why you need this, right? I mean, also it's going to be to prevent leaks, because, well, of course, if you get a small leak, well, I mean, you can, I guess you can go and fix it, but it's kind of not easy, having to dive down and, fix it, like, at whatever depth it's at. And I guess, even some unexpected reasons like this one. So this was actually something on the news, and I think people can probably see it, right? It's not the best quality. But I mean, if you can see, well, of course, it's just a shark, right, trying to eat the cable. And I mean, you might think, well, the cable is super strong, right? It's not going to be able to damage it. But I think this did actually take out this cable, and they actually had to dive down and fix it. So I guess I mean that even have these unexpected problems. Right, so then if we talk about accessing remote locations, and surprisingly, there's even many small islands with a population of just a few thousand, or even less, and even these small islands are connected with fibre. However, of course, there's still going to be some islands that aren't, or some mountainous regions that aren't. So, for example, Antarctica, right? This is not connected by fibre. So if you think back to I think maybe the previous lesson or maybe two. Right, so how, okay. So, right, let's say what transmission medium can people use, right, to access the internet, if we don't have fibre. Right, so hopefully people might remember, okay, well, of course, right, we can just use satellites. However, the speed is going to be slow and the price is expensive. And supposedly it's going to cost $3 to send an email, right, on Antarctica. I'm not sure how they calculated that. Like, maybe they just take the price of the satellite, divide it by the amount of emails, by the amount of traffic they're taking. But yeah, I mean, that's pretty expensive. Alright, so I think this one we actually have looked at this. So yeah, hopefully people can remember what the function of a router is. Like, what it's going to do, it's going to look at the destination IP address in the packet, right? Then it's going to forward the packet to the next hop, right? So the next device, right, based on its routing table. So I think probably the best way to understand that's just with an example. So suppose device 12001 wants to send to 14001. And again, okay, I think we did mention this briefly. All right, so when we say /8 like this, okay, this /8, what that's meaning is saying, well, okay, so right, the first 24 bits, because IP version 4 is the 32 bits total, right? So the first 24 bits are going to be the network, right? The network ID, right? Then the remaining 8 bits. So again, 24 and then 8, right? Okay, the remaining 8 bits are going to be for the device ID, and like. Yeah, alright, so I guess if that doesn't make sense, I mean, don't really worry because it's going to be in a future lesson. But yeah, I mean, again, kind of what that's saying, okay, well, of course, right, 12.0.0, right, that's the network. And then on this network, I guess what we can have from, 12.0.1, I mean, I suppose also 0, although, yeah, I mean, 0 is, I guess, usually reserved. Alright, then, of course, we can go, right, 12.0, and then, up until 255. Right, so of course, with 8 bits, that's 256 different devices that we can have on the network. Alright, so if we look at the routing table then, let's start then on, network 12. So network 12, right, that's going to be here. And let's say, for example, okay, this is device 1, right, device 2, device 3, right, etc. So first then, right, so it's just going to go to this, right, this is going to be the switch. I guess, then the switch is going to send it to the router. And it's going to look, so what the destination is going to be this one, right, 1400. Yes, we see the destination. Right, so then, okay, looking at its routing table, it's saying, right, send to R1. Okay, alright, so R1, of course, that's going to be here. Alright, then we look again, alright, so 14, right, then it's saying send to R4. So, of course, R4 is sent to this one. Alright, then if we look here, so network, right, 1400. Right, then it's saying direct, which I guess means kind of internal, right, just in the network. So, of course, that's going to go here. And again, probably let's say, right, device 1, device 2, device 3, etc. So of course, then the switch is then just going to forward it on to device 1. So hopefully that makes sense, right, how those routing tables work, or how they're working. And if we want to send, let's say, I guess kind of right, device 1 on, network 12, and device 2 again on, network, right, 1200. Then of course, it's just going to go to the switch here. I guess, and like this is a bit confusing because, right, if you're talking about a home network, then actually, the router and the switch, right, on a home network, they're just going to be one device. So in that regard, of course, what it's just going to look here, it's going to see it's direct, and of course, here, I mean, the packets are just going to go to the switch, right, to the router, and then of course, it's just going to forward it on, right, obviously to this device in the network. It's never going to leave the network, right, if it's sent into a local IP. Alright, so I guess routers, will like WNICs. So hopefully people remember this. Of course, right, W means wireless, right? So wireless network interface card. And actually, if you remember, right, C can have two, right? Either card, right, or controller. You can use either of those words. Right, also sound cards, GPUs, right, etc. Right, all of these components are going to have buffers. Right, so a buffer, hopefully people remember this, right, it's going to be a temporary storage area, or storage space to hold data, right, as other data is being processed or transmitted. Right, so imagine a backbone router has a maximum bandwidth of 1 gigabit per second, and I mean, well, in reality, like, I'm sure they're much faster than this. Okay, right, so what's going to happen then if it receives 1.1 gigabits, right, in a single second? Now, we don't want to drop, what, that extra 100 megabits, of packets. So because we don't want to drop them, well, then we're just going to want to have a temporary storage area, right, to temporarily store this extra, 100 megabits. And hopefully after that, I don't know, okay, yeah, maybe it's going to go back down to what, sort of 0.8 gigabits per second, sort of in, yeah, I guess, in the future. Um, and then of course, all right, so when it goes lower again, well, then of course what we can just kind of empty the, or all right, yeah, not empty, but obviously what we can do, well, yeah, we can start, sort of sending out the packets that are in the buffer. um, yeah, I mean, like, hopefully that makes sense, because of course, right, so okay, like, here it's being filled up more than we can, process the data. But of course, right, once the incoming data is what's less than, sort of, yeah, I guess, the speed we can send out, well, I mean, then of course, anything that's already in the buffer is then going to sort of, yes, kind of go out, basically. um, yeah, I mean, probably a terrible explanation, but I mean, I think, this one hopefully makes sense, right? Just a picture. So of course, I mean, the data is coming in, right? It's temporarily being stored in the buffer, and then of course, it's just, processed, right, passed on, or yeah, forwarded on, right, to the next router, right, the next hop. All right, so let's think then. Well, where a router is going to be placed, and I guess, well, one, right, they could be in a home or office, right? I think everyone knows that home router. Right, they can also be placed, well, I guess, yeah, all three of the tiers. So, well, an access, ISP, right, regional, global. Yeah, of course, right, there's going to be routers at, every stage. Right, also, any time that a cable splits, right, e.g., when an undersea cable reaches land and it splits, right, with different parts going to different regions or countries. Now, I think, like, if we just go back here to this undersea cable map, hopefully we can see that. Yeah, like, for example, I guess, well, I mean, there's kind of many places, right? Yeah, I mean, for example, here, of course, where it's splitting, yeah, and obviously, all these different directions. So, of course, right, when it splits, right, there's going to have to be a router, yeah, to determine what path it's going to take, right? And again, obviously, that's going to be determined by the routing table. All right, so to see an example now, this is not required for the exam, but, I think sometimes, right, having, like, practical experience, yeah, it kind of solidifies the concept, right, rather than just reading it in a book. So for an example, you can see here, well, I mean, I've just called traceroute, and obviously we're going to bing.com. Now, traceroute, I mean, this is just going to be a command, so you can open command prompt, right, I guess PowerShell, right, that's what they, yeah, kind of call it now. I mean, if you're on, well, Mac or Linux, right, I mean, there's going to be a different command, but I guess if you just type in, traceroute on Mac, yeah, of course, you're going to find the equivalent one, right, just search on Google. Right, so, like, what this is going to show us then, well, it's going to show us all of the routers, or yeah, all of the, I guess, yeah, all of the devices, right, that the packets travel through, yeah, before they got to their final destination. Right, and then, well, I mean, for me, like, I've just hidden some of these IPs for, privacy reasons, because, like, if we actually think, well, of course, yeah, well, I guess it's probably going to show us in a minute. Yeah, okay, so, like, right, if we think about these first two, now, actually, these first two are just, well, private IP addresses, right? They're local IP addresses. So actually, I mean, this doesn't really tell anything about privacy, since, well, other people are going to have the same as this, right? Because, I mean, well, okay, this IP is just going to be on, I guess, yeah, on the network that I'm on. So yeah, there's going to be many people in the same world, in the world, yeah, of course, with this same private IP. However, I mean, well, of course, yeah, some of these public IPs, well, that's going to reveal, location, right, various other things. Alright, so yeah, I think we said this. So again, right, they're private IPs. So yeah, they can be, let's say, the IP of, well, the office, right, your home, right, I guess, yeah, school, right, wherever you're accessing the website from. Right, then, if we look at the third hop, so, well, here then we can see it's a router owned by the ISP, well, in the city that I'm in. Again, I've blurred it out for privacy, but if you just want to try this again, well, just call, like, traceroute. Then, for example, look at some of the IPs. Now, I mean, well, here, right, 111, I mean, that's just fake, right? I've just done that. But what you then want to do, well, you can use a website, well, as mentioned, well, it's going to be IP info. Yeah, so I think this one, right, well, ipinfo.io. I mean, of course, there's also going to be other websites that show you. So it's just going to show you information about that IP address. And as you can see, well, I mean, here it's saying, well, it's, well, China Unicom, so I guess that's the ISP. And actually, like, I actually took this at work, so yeah, I mean, this, right, yeah, okay, so I guess what we can say, of course, right, this is going to be the ISP that, of course, the workplace is using. And yeah, we see, well, that's the backbone, right, just the, yeah, I guess kind of their main fiber optic, cables. All right, and then I guess, yeah, if we look at the final destination, so I mean, well, this is the website we visited, and I guess, well, here we can see, right, it's in Beijing, and yeah, I mean, that makes sense, right, considering, that's where the company headquarters are, yeah, for this particular website. All right, so I think, well, so far, I mean, we've talked a lot about routers, and I mean, we'll talk kind of more later, but basically, well, what routers do, right, it's called packet switching, and packet switching, I mean, okay, right, switching like that, right, T. Right, okay, so what this means, well, you're going to take the data, you're then going to break it down into individual packets, right, and the packets are going to be quite small. I think we'll see, like, yeah, I think they said usually, right, smaller than 1460 bytes. Alright, so anyway, what's going to happen, well, of course, right, it's going to be a split, okay, the data is split into packets, right, the packets can then be sent independently, and some of them are going to go different routes, of course, yeah, via different routers. Hopefully they're all going to arrive at the destination. Now, again, if they don't, well, right, depends if we're using TCP UDP. Actually, TCP UDP is actually not required. I mean, that's not really to do with routers, right? That's a higher level thing. Yeah, that's something built on top of routers. But yeah, all right. So like, I guess this is the key thing, right? Of course, again, right, data is broken down into packets, right? It's then sent different routes, and yeah, hopefully, right, they're all going to arrive at the destination. Right, whereas in contrast then, well, right, so this one's called circuit switching, and in particular, right, well, the PSTN, right, yeah, this was kind of the main system that used circuit switching, right, yeah, the most common one. Right, that was the public switch telephone network. And I guess, I mean, well, I think everyone has probably seen this, well, of course, yeah, a phone, and then, well, of course, right, you just got the, I guess, telephone wires, yeah, telephone lines. And of course, right, well, yeah, of course, right, they're going to be connected together. Eventually then, yeah, I guess it's going to go to some cabinet, by the side of the road, right, all these cables are going to plug in, like, to this kind of metal box. Right, and then, I mean, what MDF, I'm actually not sure what that is, right, it doesn't really matter. And then, right, okay, so this is going to be the key thing, right, this exchange. And I think, yeah, we'll see here, right, okay, so calls will be sent along telephone lines to an exchange. Right, so then if we look, so this top picture is actually the exchange here. So let's take an example, right, let's assume someone in Manchester, so obviously the UK, wants to call someone in, well, Melbourne, right, so Australia. Right, the switch operator will literally plug the cable into the London port, and an operator will then plug it into another port and so on, right, until you eventually got to Sydney, right, who could then route it to Melbourne. So, I mean, kind of what that's saying, okay, right, okay, so yeah, let's say, okay, right, okay, so, right, let's say this person here is in Manchester. Now, right, from Manchester, well, right, okay, let's say, right, this one is to London. So what we're going to do, well, of course, we're going to take, I guess this is our wire, right, this is our, well, port. Well, of course, we could plug it into here, but let's say, I don't know, okay, like maybe that's Liverpool or it's, some other city. So, of course, well, right, instead, well, yeah, we want to plug it into what, the London port. Let's say from this London port, well, of course, yeah, then we want to plug it into, I don't know, Paris, yeah, then to, I don't know, wherever else it's going to go. Obviously, eventually, let's say it's going to get to Sydney, right, and, somewhere in Australia. And then, obviously, yeah, from there, of course, well, they can then, or yeah, let's say right then, of course, well, they're just going to route it to Melbourne. So hopefully that makes sense. And of course, I mean, well, if you look here at this picture, well, you can see, I mean, what she's literally unplugging one of the cables. Then, of course, right, she's going to plug it into a different port. Yeah, just to, plug it into the different city, right, that they're trying to communicate with. However, I mean, you can probably guess, well, modern telephones are not going to use that, right? It's going to be extremely inefficient. So modern telephone, well, I guess, yeah, okay, so modern landlines, and of course, when we say landline, like, we're not talking about mobile phones. Yeah, we're actually talking about, obviously, well, these phones that are, connected to the wall, right, connected to the telephone network. Right, so here everything is going to be digital, and most phone calls travel along fiber optic cables. Yeah, but I think some of them, they still use the circuit switching to an extent. Yeah, although I guess here, probably a lot are just using packet switching as well. Alright, so yeah, and actually, like, most homes these days don't even seem to have a landline phone. I think most people just have mobile phones. I mean, like, maybe it depends on the country, but yeah, I think a lot of people don't even have landlines these days. Alright, so if we look at the PSTN, right, so the public switch telephone network, and if we think, like, how we could actually utilize that, right, for, well, I guess the old internet, right, the legacy internet. So when the internet was first getting popular, in the 90s, 2000s, I mean, I guess like if you're talking about the super old, you know, sort of what 1970s, that's when I guess ARPANET, things like that. But if you're talking about sort of commercially getting popular, right, when you had high traffic demands, I guess that's the 90s really. Right now, obviously, at that point, we didn't have the millions of kilometers of fiber optic cables that we have today. So instead, what they had to do, they had to send the data over the existing telephone line infrastructure, which had existed over the past 100 years. However, there's going to be a problem with this. One, telephone lines transmit analog signals while the internet operates digitally. So I guess to solve that, we're going to need something called a modem. Right, so a modem, that's going to be a device that's used to convert between analog and digital, and vice versa. I guess like another problem with the telephone lines, right? I mean, they're kind of slow. Obviously, I guess a lot of them are old, right? Maybe they're sort of damaged, right? They're broken. Obviously, just not as good as the fiber optic that we have today. Right, so I guess this is a typical setup then. However, it's going to be slow, and you could often only use the internet or phone, right? Not both at the same time, because so if you think about it, so like we said, like if they're both coming over the same telephone, the same telephone wire, the same telephone line, then we're not really going to be able to have this I guess two signals simultaneously, right, coming over the same wire. Now, I mean, we'll see in a minute, right? They did actually sort of develop a way to fix this, but I guess just with a simple setup, you're not going to be able to. So, for example, you might actually have to turn off your router if someone called you. And I mean, for me, I'm nearly 30, or I'm not super old, but I mean, I can still remember this problem, when I was young. All right, let's say, the phone would ring, and then like the internet would just completely stop working, right? You'd have to unplug the router. So that, this was kind of a real life problem, right? So it's not just some like theoretical thing, right? It was a real life problem. Alright, so what you'd then use, you'd use a modem, and that would convert between analog phone signals and digital internet signals. The modem, if we see, right, the modem is actually this big thing. I mean, basically what you say, I mean, basically just a router, right? I mean, that's what you'd really call it these days. Right, and the other thing, that's, where's the pen? Okay, here we go. So this one, where the cables are plugging into. Right, this is going to be the phone or internet, phone and internet splitter. If we have this setup, this setup allows the internet and phone to operate simultaneously, using different frequencies. Now, if we didn't have this splitter, right, if we only had this modem, then that's when we're going to get this, right? We can only use the internet or phone, right, not both. I guess, right, if you also bought the splitter, right, then you're going to be able to use both. Although, to be honest, I'm pretty sure we also had that, and I'm pretty sure it didn't work that well. So I definitely don't think it's some 100% foolproof method. You still get the interference. Alright, so I think let's just compare them then, because we've sort of talked about them, but not not in much detail. So packet switching, that's going to be what routers use. Right, circuit switching, what the old telephone systems use. Just have a recap. Right, so packet switching. Right here, data is sent without a connection being established between the sender and receiver. Right, therefore this means that establishing the connection is fast. However, the receiver may be unreachable, and that could be, for example, the device is turned off. There's some network error. Right, maybe some misconfiguration with the network. So what that's saying is, so again, right, let's say this is client, or just call them A. This is what the server, I could call them B. Now let's say, of course, this server could be completely offline, broken. I don't know, maybe there's a problem with this wire, right? It's just not connecting. Now, if we look at circuit switching in a minute, circuit switching will actually check first that the device is reachable, whereas packet switching is not. Now, again, the advantage of this, it's gonna, and to be honest, right, this is not that important, because honestly, establishing the initial connection, I mean, you can send data to anyone in the world in maybe 200 milliseconds. I mean, that's generally the sort of latency, right? I mean maybe 400 milliseconds if it's super far. I think generally less than probably, I don't know, 200 or 300 milliseconds usually. So I think honestly, having to wait probably less than a second, for sort of a round trip, and maybe you have like a three-way handshake, so you have to do I guess kind of a request. Right, then they would acknowledge it, and then they would confirm they received the acknowledgement. But even if you think, okay, let's say each one is taking 300 milliseconds, well, you know, I mean, that's still that 3-step process, right? You know, still only 1 second. Well, yeah, 900 milliseconds. So yeah, I don't really think it's that much of an issue, really. Alright, so, right, okay, then we said, well, the router, they're going to forward packets onto the next hop based on their routing table. Yeah, I think we saw that. Right, so data, well, let's say an image, right, we mentioned, so it's going to be split into many smaller packets, right, usually, well, not larger than 1460 bytes. Right, let's erase that. Okay, well, packets may travel different routes or arrive out of order. Right, they will then be reordered at the destination, right, if using TCP. And I mean, you might think, well, why 1460? Right, seems quite a weird number. Now, I'm actually not sure exactly. Like, I think what I read is that I think Ethernet frames can only be, well, you know, 1500. Right, I mean, that's the limit. And I think you've then got about 40 bytes of header. So if you say, well, right, of course, if you have 40 bytes of header, well, therefore, of course, what you can have, you know, 1460 bytes of actual data. Yeah, I think that's generally like a typical setup. And again, hopefully this makes sense, right? Of course, well, packets can travel different routes. So of course, yeah, one can go this way. Yeah, of course, I know, you know, another one can go this way. So if you think, well, the advantage of that, right, is going to be reliable because, well, right, okay, yeah, let's say like this device stops, or yeah, this router stops working. Well, then of course, you know, rather than going this way, well, instead, of course, yeah, it's just going to go, you know, this way, right, as we saw. Yeah, however, the disadvantage, well, because, you know, the packets are going different ways, right, then they're not, I mean, well, right, so they're possibly not going to arrive in sequence, which means, of course, well, we have to reorder them at the destination. Although, again, okay, we're only going to reorder if using TCP, right, if using UDP, well, then we just send the packets again, right, if they receive them, I guess good. Yeah, if they don't receive them, well, yeah, you know, don't really care, right, it's just audio, video. Right, so the advantages, well, it doesn't require dedicated infrastructure for each user, right? Many people can share the same, I guess, cables, yeah, e.g. fiber optic cables. And because, well, yeah, all right, so because many people are sharing the same cables, right, of course it's going to be cheaper, right, also more scalable. Now, if you, yeah, all right, so, okay, let's go back to this picture here, right, okay, yeah. So, right, if we think here, right, the PSTN, right, telephone exchange. Now, obviously, I mean, now this can be automated, right, so it's not much of an issue. But like, imagine if you had like 1 billion people trying to use the internet. Like, I mean, yeah, I mean, like, I guess like just think how much of a nightmare that'd be, right? How many people you would need, like, you know, well, plugging in cables, unplugging cables. I mean, like, yeah, I mean, honestly, like, you'd probably need millions of people just doing that. Whereas I guess, yeah, packet switching, of course, it's more kind of automated, right? It's just being sent whatever way. And then obviously, well, yeah, and then obviously, right, it's going to be the router that's determining where to send it. Right, so as such, well, there's going to be a better utilization of hardware because, well, let's think about circuit switching, right? If we have a dedicated connection, so right, let's say this is our connection. Now, let's say, for example, like this wire, well, maybe this wire can support, you know, 1 gigabit per second. But let's say you're only using this wire to make a phone call. Now, I mean, like, what's going to be the actual bandwidth of a phone call? I mean, I don't know, it's probably not much, maybe like 100 kilobytes per second. Yeah, like maybe even less, or in fact, well, let's say bits. Yeah, just to keep it the same. So obviously, like, I mean, in that case, you're saying, well, okay, right here, the connection can support, right, 1 gigabit per second, but, you know, our phone call is only using, right, 100 kilobits per second. So of course, yeah, I mean, that's kind of quite wasteful. Right, so packet switching, well, can be faster. I put that in, well, orange italics. And I guess, well, the reason it can be faster, well, packets can be sent along the fastest route, and, well, hopefully, again, you know, I guess, yeah, kind of assuming the routers are working properly, right, assuming the routers, have, yeah, calculated the correct route. And, like, we can also say, I mean, since packets can be split, then in theory, well, of course, well, some packets can go this way, some can go this way, so you can kind of send them simultaneously, right, yeah, therefore, of course, it could be faster. Whereas circuit switching, well, right, okay, if we think here, right, this is our wire, well, circuit switching, of course, well, it's all just going to go in a continuous stream. So, of course, well, obviously, yeah, packet 1, or, like, okay, so obviously, yeah, packet 1, packet 2, packet 3, yeah, just in order. Okay, then this one, I think we mentioned, right, we said, well, no connection required, right, you can also call that connectionless. Yeah, this means a lower initial delay, right, lower latency, because again, right, you don't have to check they're available, right, you just send it. Alright, then, well, reliability, so, I mean, in some ways it's reliable because, of course, right, if one router goes down, well, you just send it a different route. Yeah, I mean, I guess you can also say, well, in some ways it can also be unreliable because, well, like, yeah, maybe the connection is not available. Yeah, maybe the packets arrive in the wrong order, you know, things like that. Or, yeah, the packets just don't arrive at all. But again, of course, well, you can use something like TCP, right, to add that reliability in. Right, well, let's look at the disadvantages. Well, one, packet loss, right? Some packets might not arrive at the destination. Again, well, misconfigured network, broken router cabling. Yeah, even full buffers, right? If the buffer is full, yeah, obviously it's not going to be able to, take in any more data or any more packets. Right, I guess another disadvantage, well, packets arrive in the wrong order, although, of course, right, they can be sorted at the end. Right, also variable latency, so some packets are going to travel a quick route, some packets are going to travel a slow route, and you might have a situation where, let's say, you're just waiting for one packet to arrive, and of course, yeah, like you can actually process those packets that have already arrived, right, until you get the one that you're waiting for. And I mean, this one again, like I've put these in orange since they're honestly not that important usually. Right, so header overhead, right, small amount of extra data needed in every packet. And, well, yeah, every packet header, right, and some of those things, well, for IP, it's going to be the source and destination IP. It's also going to be the packet length, right, so just, checking you've actually got all of the data. Right, there's also going to be a version number, so whether it's IP version 4, IP version 6. There's going to be a checksum, and that's basically used to verify the integrity of the data, right, so checking it's not been corrupted. Right, something called the time to live. Now, this one, right, this is A2, but just quickly, if people want to know, basically what this is going to do, because, well, alright, so you could have a situation, alright, let's just, alright, I'm actually going to do it as circles. Alright, okay, so let's say this is our router. Now, you might have some fault in the network where, okay, let's say this router sends to this router sends to this router, right, this router sends to this router. So as you can see, well, this is just going to be an infinite loop, right, the packet's just going to be sending infinitely. Now, what you'd actually do, okay, each packet is going to have a time to live, and, like, let's just say that's 100. And, well, I think in reality, usually it's like 255, right, 256. But okay, yeah, well, let's say 100. Now, what's going to happen is, well, each time it kind of arrives at a router, well, each router is going to decrement this time to live. So, I guess, alright, okay, so let's say here, right, this is where I'm sending it from. So, okay, when it gets to router 1, well, right, then the time to live is decremented to 99. Right here, right, then it's decremented to 98, right, then, well, 97. Right, now when we get back to this one, well, right, so here it's going to be decrement again, right, so 96, 95, right, etc. Now, eventually, of course, what we're going to get somewhere is going to be 0. Now, if the time to live has been decremented to 0, well, then we're just going to drop the packet, because at that point, well, we're going to assume that there's been some error, and yeah, I guess the packet's just going to send round and round in a loop. And if you think, well, the reason we don't want the packets to be sent round and round in a loop is because, well, otherwise, the network is just going to get clogged up, right? Eventually it's just going to be completely full, all right, just with the same packets going around and around. So, of course, yeah, that's why you need to add that. And again, some of these issues are actually not that important because, well, for example, rerouting, so the packets go in different ways, right, if there's an error. And again, right, high-level protocols like TCP, right, that's going to sort of mitigate against some of these issues. Right, then if we look at circuit switching, so there's a physical link between the sender and receiver as required. Right, this could be with someone on the other side of the world, so there could literally be a cable, 10,000 kilometers, right, connecting, right, your device to their device. And of course, yeah, that's going to be since it has to be unplugged and then plugged in, right, to the correct port. Right, the connection must be established before communication can begin, and I'll put this in orange because, like, in some ways it's a good thing, right, of course, well, of course, like, you're kind of guaranteeing that they're available. Obviously, it's a slightly bad thing in terms of what the initial latency is going to be a bit higher, right, because you have to wait for that, confirmation they're available. Right, so, and again, well, this is kind of good, kind of bad, right? Channel is dedicated for only these 2 users for the duration of communication. So it's good, well, it's fast, it's reliable. Yeah, I guess it's also private, right? It's secure, right? That's going to be another thing. However, a disadvantage, well, you can say what low utilization of bandwidth, right? Also, it's expensive. Again, it's not scalable. It's not realistic that you'd have 1 billion people using the internet, and you'd have like 1 billion different dedicated connections for each person. All right, so yeah, okay, so I guess one problem they could have, right, because people are sharing the lines. Now, you probably wouldn't want to have, like, I don't know, let's say, right, a company or like government, hospital. So if you have some big, like, important organization like this, well, they wouldn't really want to be sharing the lines with just regular people, because you might have a situation where, well, like, okay, so right, let's say if all of the wires were being used, right, if all of the ports were being used, then they wouldn't actually be able to connect. And of course, right, I don't know, okay, well, yeah, I guess here they say office, but like if this is like a hospital in one city, right, and they need to communicate with a hospital in another city, well, it's going to be pretty annoying if, they're trying to communicate, but they just get, I guess, yeah, all the lines are in use, like, try again in 30 minutes, like, yeah, as someone is, like, bleeding to death or whatever. So I guess because of this, right, if you wanted a reliable connection, well, then you can actually rent a permanent line. And yeah, of course, well, that's why it's going to be called leased, because, well, lease, right, that just means to rent. So, of course, yeah, they can just rent a permanent line. And of course, like, when we say permanent line, I mean, right, so again, like, if we just sort of draw those telephone wires, so of course, what we say the telephone wires like this, so what basically, yeah, basically they could just rent one of these telephone lines. That's kind of what that's saying. Right, so the advantages then, well, one, right, it's going to be reliable because, well, we're ensuring the receiver is reachable. Right, so I guess, well, dedicated channel required, so it can be an advantage, right, again, reliable high bandwidth, right, or disadvantage, right, is wasteful, right, we're not using the bandwidth well. Right, it's also suitable for long continuous communication, right, e.g. phone calls. And again, that's because, well, right, if we start the call, then we know it's going to be available the entire call. Right, data will also arrive in the correct order, right, just the order we send it. Right, also this one, system has many backup generators, right, so you can make a phone call in an emergency, e.g. Let's say there's a flood or something like that. Yeah, since, I mean, well, when it says backup generator, it's talking about power generators, right, electricity. Right, have disadvantages, well, if all channels are being used, then you won't be able to connect, right, hence you might need a leased line. And obviously, well, a leased line, right, for, for some huge company, I guess is suitable. For an individual person, well, of course, they're not going to be able to afford, to rent a permanent line. Right, also higher costs, well, again, because of this dedicated channels, like, whereas if we think, well, obviously packet switching, right, everyone can share, right, therefore it's going to be cheaper. Right, and then, well, your high initial latency, right, due to, ensuring the receiver is available. And I think actually for the advantages, like, we can also probably say, well, it's going to be secure, since, again, what you have that dedicated line. Although at the same time, you can also say insecure because, well, traditionally, right, it's not been encrypted. And actually, you can also say it's less secure in it from another point of view because, right, let's imagine, okay, well, you're trying to be like an eavesdropper, you're trying to listen in. Now, if you know that what person A is communicating with person B, and right, if you know that all of their traffic is going through this one wire, then, like, in many ways that's quite easy, right? Because I mean, all you have to do is just listen into that one wire. Right, whereas if you think, right, okay, let's say packet switching. Well, I mean, obviously packet switching, okay, some of them are going to be going this route, but of course, some of the packets are going to be going this route. So in that case, like, if you're an eavesdropper, I mean, that's going to be much more difficult, since in effect, I mean, what you're kind of having to listen to, like, multiple different routers. And yeah, I mean, let's say this is B. Yeah, alright, so I mean, right, okay, so for example, in this case, of course, well, like, in this case, well, they would have to have access to both this router and this router, yeah, in order to actually, kind of get the whole message that B is being receiving. Yeah, so I mean, that's the thing, again, these are not kind of like definite advantages, definite disadvantages, it really depends on the situation. Alright, then, well, let's have a look at this exam question, because, yeah, this is quite difficult. So telephone calls being made, right, using conventional telephones, right, using the public switch telephone network, PSTN system, right, over a wired network. Or then the other situation where a computer, right, well, speaks a microphone, right, that's connected to the internet. Right, put a tick in the correct column to match each description. And I think maybe some of them might have two, possibly. So if we say this, right, connection is only in use while sound is being transmitted. Now, if we think PSTN, well, PSTN, right, they're actually renting the line for the entire phone call. So, yeah, it's definitely not going to be that. Alright, but then if we think, well, the internet system, right, so packet switching, and yeah, wait, here's the pen. Alright, okay, so packet switching, well, this is going to be true because, like, while they're not speaking, I guess what they're saying, well, no packets will be sent while they're not speaking, right, if there's just silence. So yeah, right, okay, yeah, here it is. Right, okay, so of course, yeah, that's going to be this one. Right, dedicated channel used between 2 points for the duration of the call. So this is actually just the opposite of question 1. So, okay, that's going to be this one here. Because, well, as mentioned, right, okay, if they're calling for 10 minutes, well, they're basically going to be renting that line for 10 minutes. Right, that's why it was expensive. And that was also, well, one, why it's more expensive, right, the longer you call someone. And 2, also more expensive, right, I guess, yeah, the longer distance, or yeah, if it's an international phone call. Because if you think, okay, well, right, let's say you're A, this is B, right, if you're calling someone, let's say in a neighbouring city, well, I mean, you're, of course, right, you're only renting a short distance of line. Whereas, you know, I mean, let's say here at C, like if you're calling someone on, you know, the other side of the world, of course, right, you're renting a lot more line, right? Therefore, it's going to be more expensive. Right then, connection maintained throughout the entire telephone call. So, I mean, actually, yeah, this is super weird because, like, this is literally the exact same as number 2. Yeah, I mean, of course, you know, these two are the exact same, right? Dedicated channel, right? Connection maintained. Right, encoding schemes and compression technology. So I guess what PSTN, right, is quite simple, just analog data. Yeah, no encryption or anything like that. Whereas I guess, yeah, the internet system, right, that's going to be encrypted, encoded. However, well, the advantage of the PSTN, well, that's going to be this one, right? Okay, so yeah, lines remain active even during a power outage, and again, that's because of the backup generators. I suppose the PSTN, you know, it's more of a kind of national security requirement. Like if there's a flood, if there's a wildfire, people need to be able to contact like the emergency services. You know, of course, what contacting the police, the hospital, the fire engine. So of course, yeah, that's why it has all of these backup generators. Whereas, yeah, I guess the internet. I mean, I don't know. Like these days, maybe the internet does also have these backup generators, but yeah, traditionally, like maybe the rules are less strict. Alright, and then yeah, I guess here's just the answers. Alright, then I think, I mean, this one, right, I'm not really going to explain it because this video has been super long already. So I'm just going to, okay, what you can do, right, pause the video, have a go at these, and then of course, yeah, just read the answers. So yeah, I guess, well, that's the first one, right? Network of interconnected devices, right? Routers, cables, etc. Packets routed based on the IP address. Right, supports World Wide Web, right? Email, media streaming, right? Peer-to-peer downloads, etc. Right, then in contrast, well, World Wide Web, it's the collection of all interconnected web pages and can be accessed over HTTPS, right? Hypertext Transfer Protocol. And obviously, yeah, S means secure. Right, next one, we'll explain how packet switching and circuit switching route packets to the correct destination. And I guess actually, like, this shouldn't really be packets because, well, right, in packet switching, you call it packets. I guess we're in circuit switching, well, I mean, you just call it data. Alright, so yeah, again, pause the video, have a go. So packet switching, while data is split into packets and forwarded by routers to the next device based on the routing table, right, until the packets arrive at the destination. Right, okay, so well, here it's going to be connectionless, right, packets sent without connection being established. They're going to travel different routes and may have to be reordered. And again, I've put these in orange because, well, like sometimes they can be an advantage, right, if we're talking, let's say, low speed. However, of course, well, it can also be disadvantage, right? I mean, let's say what the device is not available. Of course, yeah, obviously, while the packets arrive in the wrong order, right, it takes time to reorder them, right, etc. Right, in contrast, well, circuit switching, there's going to be a physical dedicated cable link connected between the sender and receiver. Yeah, that's going to be required before communication can begin. So again, orange because, well, one, it's reliable, right, that's a good thing. Obviously, yeah, bad, well, it's, you know, what, higher initial latency. Right, data will be sent as a continuous stream and previously involved humans, right, manually, well, I guess, yeah, unplugging, plugging in, right, so switching cables at a switching office, or I guess, well, I mean, they also call the switching office an exchange. However, yeah, this is now automated. Right, then I think finally, well, just some advantages, disadvantages of packet and circuit switching. Right, so circuit switching, well, it's, yeah, reliable, dedicated, well, okay, right, so it's reliable because of the dedicated high bandwidth connection. Right, it's suitable for long continuous communication, however, of course, it's expensive. Right, data is going to arrive in the correct order. Right, backup generators are used for emergencies. Right, so okay, you could have a situation where all channels are being used. Right, then of course you can't actually make your phone call, or yeah, you couldn't, you know, access the internet. Right, it's also going to be expensive due to the dedicated connections, right, and also higher initial latency. Right, then finally, well, packet switching, right, fast, reliable, and well, reliable due to rerouting. Of course, yeah, packets can go a different route. Right, and well, okay, that's because of, well, shared transmission mediums. Well, all right, okay, yeah, all right. So, okay, right, the rerouting is not because of shared transmission mediums. Obviously, okay, right, yeah, the rerouting, well, that's because, right, we have multiple routers. Right, but we say, right, the shared transmission mediums, well, that's going to make it cheap and also provides a better utilization of, well, the hardware of the cables. Right, since it's connectionless, it has a lower initial delay. Right, however, there's going to be some packet loss because, well, maybe some of the routers are broken. Yeah, some of the cables are broken. Could also just be misconfiguration. Yeah, the sort of routing table has, you know, become, yeah, I guess become invalid. Yeah, I guess, you know, out of date. All right, well, packets can also arrive out of order, although again with TCP, right, of course, yeah, we can fix that. Also, well, variable latency, right? They're traveling different routes. Some are going to arrive first. Some are going to arrive, yeah, I guess, well, out of order. And also, again, well, I guess the overhead of the header. Although I think, I mean, as mentioned, right, the headers are relatively small. So yeah, that's probably not too much of an issue. And yeah, alright guys, so I think that's going to be all for this video. Again, super long. But yeah, hopefully that's useful, and as always, any questions, just ask in the comments, and see you again in the next video.